day.
It's just 2 today, right?
Sorry?
It's just 2 packets in there.
That's correct.
Thank you, Mr. Housen.
Thank you. See you tomorrow.
I'm twitching. So chilly. What are you doing? Oh, you're got goosebumps, eh? Oops.
Oh wait, yeah, she said that. She's like, I know who you are. I remember
Yeah, I don't know.
That made me so mad.
She was like,
Wait.
nobody.
I was like, you're absent. Oh, I would have done it.
Because I'm in the queue.
Yeah, I actually already got my test.
Really?
I think I already like, I was like,
I'm gonna be so mad at him. Oh yeah, I know.
That's just these from you? No. Okay, it's fine.
Do you have any sticky notes?
You can have one or two, but you can't take a whole stack of them. All right, good morning, guys. I need y'all to get out a blank piece of paper and assignment 15 from last class. Girls, settle down, please.
There's nothing on my team sheet.
I'll say that too, girl.
Instead of 55, he would be in. It is 10 minutes to get my figure.
That's a lot of pressure. Because last time, when I got Vincent Raymond against the Q, I got her at 10. Oh, yeah. She was 85. So,
No, I've already done the Q. So you guys watch the Q, and then you decide your idea. I hope you can push the button and then put in my card and then put in my card.
Okay, we need to get started here. Guys, if y'all cannot settle yourself down, I will just count you tardy. Y'all need to be ready to go. The bell rang over a minute ago, and I asked you to settle down multiple times. So I'm not going to give you that warning in the future. When the bell rings, you'll need to start getting ready for class. Okay, you should have out a blank piece of paper already, and you should have out assignment 15 already, because I asked you to do that. After the bell rang, I said that. So we need to finish that up. And then you picked up two things on your way in. One is going to be the next set of notes after we finish 15. And then 17 is a book assignment. Now, one of the two handouts you picked up is a copy of the book. That is not your copy to keep. Those questions, that the book problems that I copied off for you, I need this handout back. This is not yours to keep. Again, I've got these pages on our class website. Yesterday on Google Classroom, I shared the entire digital version of the entire textbook. And remember, you're welcome to check out a hard textbook. But I will try to just do these nice, short little handouts so you have exactly what you need. But that is dependent upon y'all returning these at the end of class. If 5 people take them, then I don't have a class set, and then I just it's too many copies to run off for everybody. Okay, so last class after our quiz, we started talking about what a derivative was, and we were doing this on assignment 15. And I think we have just a little bit left. We're a little bit behind everybody else. So let's do the 2-minute review of what we talked about last class, finish up these notes so we can do the next notes, and then we can practice the questions for you to actually, what you need to be able to do. Okay, so we started talking about slope, and if slope is a linear line, we can either count rise over run if we have a graph, or we can look at the equation and if it's linear. But lots of stuff in calculus has some curvature to it, so that is where the idea of a derivative comes in. So derivative basically means slope. What I showed you, if you took 2 generic points, plugged them into the slope formula, and then try to get the second point as close to the first point as possible, you can discover what the definition of a derivative is. And after that, we did one definition of a derivative, or we found a derivative by using the definition. This is the only time all year we have to do that. But I really need you to understand there's a difference between the derivative versus the derivative at a point versus the equation of a tangent line. All very similar stuff. Very similar work, but the way you should format your answer looks quite a bit different. We talked about that in the calculator. We talked about, this was the standard definition. You'll need to memorize this before our next quiz. So you don't need to memorize it between now and tomorrow. Tomorrow is a B-day, by the way. And there's an alternate form, but all your AP exam will expect you to do with the definition of a derivative is memorize these two so that you can try to do process of elimination and narrow these down to a single choice. So I'm actually going to have you practice this on Khan Academy at some point this unit, because it does take a handful of these before this generally clicks. But it looks like we have one more of these to do. I did not ask you to do number 10. Is that correct? Okay. So I would look at all these choices, and I see all of these choices look very similar to the standard definition. Bless you. Look similar to the standard definition. They're all over h. They all have the limit as h approaches 0. So there's only a couple things that are different here. So once you have this memorized, this top left part is supposed to give you a hint about which one is correct. This is supposed to be the function with x plus h plugged in. So here's e to the e plus h, e to the e plus h, e to the x plus h, and e to the x plus h. Now, you might be tempted to narrow it down to c or d because these have x plus h plugged in. But sometimes they put this in terms of x, and sometimes they're going to plug in the value you're trying to find the derivative of in for x. And it just depends on the question. So I feel like I can't narrow it down from that. Over here, though, this is supposed to subtract the function. So if the function is e to the x, I expect to see an e to the x here, or here, or here, or here. So how come none of those say e to the x? Right, so for this question, they chose to go ahead and plug in that value. So it needs to be e to the e, so not a or d. Bless you. Between b and c, which one do you think? Okay, why not c? B is correct, but why not c? Right, if you're going to plug in e for x, then you need to plug in e for x. You're not going to plug it in one time and not the other time. So here they plugged e in for x and they plugged in e for x. So again, you really have to have those two forms memorized, and you do have to practice trying to narrow down and think about what part is supposed to be the function, what part's the function with x plus h, what is the derivative you're trying to find the value of. We'll actually practice that another day, but we did talk about that last class. Okay, we also need to talk about when a function is differentiable or not. So using this graph for the next few questions here, I'd ask you about the slope at x equals 4, but notice that x equals 4 doesn't even exist. So if the function doesn't exist at x equals 4, how is there a slope at x equals 4? So I would say it does not exist. Same idea with x equals 6. If I asked you what's the slope at x equals 6, I don't know. Some of you might think it's here, some of you might think it's here, but it's really at this instant, and that doesn't make sense. There's not really a slope at the instant x equals 6. So other than these two both being does not exist, what else do they have in common? Right, they are discontinuous. Even better if you realized it was removable. Well, actually this one's a jump, but so to be continuous, to be differentiable, differentiable is just a fancy word that means you can take the derivative of it. If something is differentiable, it is automatically continuous. It does not make sense to be able to take a derivative. Remember, derivative means slope. It does not make sense to take a derivative if it is not continuous. So this 14 is not a big deal right now, but it's, I don't know, it might be helpful if you program yourself for it. There are a few FRQs that the AP exam gives where they might tell you in a question that maybe f of x is differentiable, and they expect you to say, because it is differentiable, it is continuous. Even though mathematically that is always true, I have seen several where you lose a couple points if you don't say that. So my suggestion, just while this is on here, fresh in my head, if you see that a function is differentiable in an FRQ, you should probably just write that down, and then if you needed it, you might get a point or two for it, and if you didn't need it, it didn't hurt anything. So that's why there's that. Okay, so to be differentiable at a point, it has to be continuous, which you should now know that implies three different things. It implies there's a point there. It implies that it approaches the same number from the left and the right, known as the limit, and the point there needs to equal the limit it approaches there. So one requirement to be able to take a derivative at a point is it better be continuous at the point. If there's some break there, then it doesn't have a slope there. If it doesn't have a slope there, then it doesn't have a derivative there. Okay, also to take the derivative at a specific point, the slope must exist. And I'm going to talk about that down here in question 17 in just a second, so you know what I'm talking about. And then the last part is your slope / your derivative can't change drastically at an instant. So a quick verbal way to say this is that we may not take the derivative at a cusp. A cusp is when you've got a sharp turn to your graph. And very, very rarely do you need to describe this in mathematics terms. But what's happening here is the slope before and the slope after are not equal. The slope before is something positive, the slope after is something negative. Your slope can't be changing that drastic at an instant. So we would say something like, I don't know, the derivative at A from the left has to be the same as the derivative of A from the right. The slope has to be the same. But most of the time it's just visual. If there's a cusp, you may not take the derivative there. So in the graph above, we already said you could not take the derivative at 4 and 6 because it's not continuous there. Where else can we not take the derivative? Good. 8 is a cusp. Doesn't make sense to take the derivative there. X equals 8, even though it's continuous at x equals 8, the derivative does not exist. Okay, and then finally, back to this part. If I asked you about the slope at x equals a, this is a vertical line at this instant. What kind of slope does a vertical line have? Undefined. Horizontal lines have the slope of 0. Vertical lines have an undefined slope. And if you don't have a slope, then you don't have a derivative. Slope and derivative mean the same thing. If the slope is undefined, meaning it doesn't exist, during that time then there's not a derivative that exists either. Okay, I know I'm saying some of that pretty quickly, but that's because y'all are a little bit behind the other classes. Is there anything you want me to quickly clear up about the rest of this? I would leave this out, by the way. You might want to reference it a few times. Okay, so 16 is a handout you guys picked up this morning. So this is where I'm going to give you all of the quality of life things you need to memorize. I say quality of life because the alternative is always using the definition of a derivative. Now, I'm not going to focus on the definition on this page, but you may note, and you may want to write on here, sometimes instead of saying h, they'll say delta x. Delta x just means to change in x, so if that bugs you. So we don't like to do derivatives by definition. We just do too many derivatives. We will do thousands of derivatives this year. So we're going to learn some of these shortcuts. So the first shortcut is called the constant rule. And just to give you some context here so you're not completely just memorizing, if I try to graph this, y equals 6, what does y equals 6 look like on the graph? Okay, horizontal, which means it has a slope of what? Which means its derivative is what? 0. Same question. Derivative and slope are the same thing. So that should make sense. 6 is always 6. It doesn't change. It's not going up. It's not going down. It's flat. its rate of change, its slope, its derivative is 0. So what this constant rule says is this: anytime you take the derivative of a constant, it will be 0. So the derivative of -2 is 0. It doesn't change. Derivative is measuring how something changes, just like slope measures rise over run, same thing. Okay, by far, probably our most popular one is going to be power rule. And in fact, a few of you probably have already heard of the power rule before. And the power rule says this: if you want to take the derivative of x to the n as the same as n to the n times x to the n minus 1. So all they're really doing is they're taking the exponent n, they're bringing it down out front, n comes down out front, and then whatever the exponent was, you're going to take away 1 from it. So the derivative of x squared, you would bring the power down and then lower the power by 1. The derivative of x squared is 2x. Now, you can do that with the definition of a derivative. You could plug x squared into the f of x plus h minus f of x over h, do all the algebra, do all the simplifying, take the limit as h approaches 0, and you would also get 2x. This is just way faster. Okay, so power rule here, bring the 8 down and then lower the power by 1. If you want to know the derivative of x to the 5th, you bring the power down, lower the power by 1, 5x to the 4th. And then even something as crazy as x to the 1,000th would have a derivative of what? Good. Power rule is super easy to apply if it's in this format, which is a lot of what we'll talk about today. X to some power, x to some power, x to some power, x to some power. Those are ready to go for power rule. Now, the constant multiple rule, this is consistent with what we did with limits. So you don't have to do this every single question all year, but I'd like you to do this for the first one, please. If you have this constant multiple, so you've got a number times a function that you want the derivative of, you can either worry about the constant later and do the derivative of the other part. You get 4x. And a lot of times that's going to make the most sense. If there's a constant here, deal with it after the calculus. Deal with it after the derivative. It's going to make it twice as big. But honestly, for this question, you can really just do the power rule. When you bring the 2 down, since there was already a 2 there, those get multiplied together. And then you lower the power by 1. You can see you get the same thing. But if there's a constant, you're welcome to deal with the constant after the derivative. 3, I can do after doing the power rule to x to the 8th. 1/2 x to the 5th, I can deal with the 1/2 after I deal with x to the 5th. Just 5/2 x to the 4th. Or, it's totally your option. When you do the power rule and you bring that down, if you bring down 1,000 and there was already a 4 there, those just get multiplied together. Either way, those end up being the same thing. So that one's not too hard to learn after we practice it a bit. Also, adding and subtracting work like limits. So if you want to take the derivative of something plus something, something plus something, you can do them separately and then add. And if you want the derivative of something minus something, you can do them separately and then subtract. That's the same thing we did with limits, which this is very handy because some of our functions are going to have lots of terms to them. So I can just do the power rule here, do the power rule here. I just get to do those one at a time. If you can do the power rule, you can do the power rule 2, 3, 4 times, whatever's necessary. So notice there was a plus sign in the middle, so I threw a plus sign in the middle. Next one's got a minus sign in the middle, so I know I'm going to subtract those. Bring the power down, lower the power by 1. What about this? What do y'all think the derivative of 7x is? 7. So you can think of this in 2 ways. seems a little different. But if you do the power rule, what's the exponent on x? So I bring the 1 down, 7 times 1 is 7. I lower the power by 1, and what's x to the 0? 1, because anything to the 0 power is 1. So that's why it's 7. Or you could even think of this as 7x plus 0. So it's like mx plus b. What would the slope of this be? 7, which is, slope is the same thing as derivative. So you can think of that a couple different ways. And I just threw in a minus sign. Okay, I'd like you to try this one, please. Try all 4 of those terms, just to make sure that you're not off on something before we throw a few more in. Okay. Johnny, you want to share what you got?
I didn't get this one actually. I was a little stuck.
Okay, we'll do the power rule to this.
2 times 5x to 4 power
Okay,
minus 3 times 2x to 2x. Sorry.
okay, so that would be 6x. Okay,
9x to the 8.
good.
And then 4 times 4x to the third.
Which ends up being,
16x to the third.
see, you can do that. Everybody okay with those? You can do the power rule. You can do the power rule multiple times if needed. It's not any harder, it's just a little bit longer. Okay, some of the other stuff we need to memorize so that we're not just doing the power rule 80 million times and only 70 million times is we will have to know the derivative to all 6 trig functions, which I will ask you to memorize. I will show you the other 4 tomorrow, because again, tomorrow's a B day. But to get going and get some derivatives under your belt so that we can start practicing some of this, these 2 are by far the most common of the 6. The derivative of sine is cosine, but the derivative of cosine is negative sine. You need to be careful. One of these switches to the other one negative, and the other one switches to the other one positive. You need to make sure that when you memorize those, that you memorize those correctly. The derivative of cosine is negative sine. The derivative of sine is cosine. And if you memorize those 2, then we can do like what we did on the other page. This becomes this. This becomes this. And you're done. This is going to be 3 times the derivative of sine. This is going to be 4 times the derivative of cosine. Why is this a plus sign? Right, it's minus a negative. Derivative of cosine is negative sine. Super easy to use, but you have to memorize. Okay, I've got 3 more I need you to memorize, and then we'll talk about a couple question types, and then we can move on. So e to the x is also a very common one. This is one of the few functions that is its own derivative. E to the x grows at the rate of e to the x, so super easy derivative. You want derivative of e to the x, it's e to the x. If it's 5 times e to the x, it's going to be 5 times the derivative of e to the x. If it's 2 times the derivative of e to the x, then it's 2 times the derivative of e to the x. Derivative of e to the x is e to the x. Easy one to remember. And because of that special property that it is its own derivative, we see lots of questions with those. Okay, we also do logarithms. This is the one that's by far the most important. This one is much less important. In fact, I'm not sure why I even bother telling you this one at the beginning of the year, but it's okay. We can finish in the notes. If you want to know the derivative of natural log of x, it goes to 1 over x. So every time you see natural log of x, we memorize that it is 1 over x. Next question, it's just going to be 2 times that. So 2 times 1 over x. And then the next question is kind of a mix of the different ones we've talked about. So what is the derivative of 2 natural log of x? Okay. What about minus 4e to the x? Okay. And what about plus 8 cosine x? There you go. So obviously these different things we're memorizing could be thrown together, but that doesn't make them any harder. It just means you've got to know more things per question. Okay, again, this one, honestly, we don't use this one much, so I know I'm going to have to retell it to you again before the AP exam, but just for your notes, we'll go ahead and fill it in. Just like you did, the natural log of x gave you 1 over x. If I'm doing the log of x, I'm going to get 1 over x. But if the base is not e, natural log, then you need a natural log of the base. Actually, let me switch these around. So whatever you're taking the log of goes in the denominator times the natural log of the base. I could do that here. This could be 1 over x, and then in the denominator put the natural log of the base. But what is the natural log of e? Okay, so this just becomes 1 over x. Now doesn't that make sense with the other formula? Because log base e is really just natural log, right? So that's really that one that we just talked about. And this one would be 1 over natural log of x times natural log of 9. Again, that's not important right now, but it's good to have it for your notes. Okay, a lot of what we will struggle with and need to get under our belt, the hardest part of our book assignment today, is that the power rule is pretty easy to use, but it has to be written a certain way. So if we have this is not one that we memorize, we just figure out how to work with it. This is not in the format to use the power rule yet. To use the power rule, you need it to be like x to some power. So we could rewrite this with exponent rules. That positive 2 exponent in the denominator is the same as a negative 2 exponent in the numerator. And now that it looks correct, we can do the power rule. Bring the power down, lower the power by 1. And the last thing you need to know is that negative exponents are considered unsimplified. So I made that a negative exponent at the start of the question so I could do power rule, but I needed to move this back to the denominator so that it had a positive exponent. So all I'm saying is you can't just use the power rule whenever you feel like it. You have to make it look a certain way. It's got to be the right format to apply the power rule. Okay, same with this guy. This doesn't make sense to do the power rule yet, but if you change the 5th root to an exponent of the 5th, now it is in the right format. You can bring the power down, lower the power by 1, and then rewrite your answer to have positive exponents. So you can see the rewriting sometimes is exponent properties. It could be radicals, changing those to exponents as well. Or it could even be one like this, which we've had a few different ways people have suggested doing this one. But what I would suggest is exponent rules again. So let me give you an easy question so that you can see you already know how to do this. What is x to the 5th divided by x to the 4th? Okay. Why is it x? Good. When you divide things with the same base, you subtract the exponents. So right here, again, you may not just take the power rule of the numerator and then the power rule of the denominator and slap a division sign in between them. I didn't say that was one of our properties. We can't do that. What we can do is we can say this is like a half, this is like 1, and when you divide things with the same base, it's like subtracting the exponents. Okay, now that I have rewritten it in the right format, now I can think about calculus. Bring the power down, lower the power by 1, and if you have a negative exponent, you need to move it to the other side of the fraction to make it be a positive exponent. So power rule's easy. That doesn't mean that the setup is easy. Sometimes you've got to split apart fractions. Sometimes you've got to subtract exponents based on exponent rules. Sometimes you need to change square roots into exponents of a half. Sometimes you need to change fifth roots into exponents of a fifth. Sometimes you have x's in your denominator and you need to move them to your denominator. Anytime you can do some algebra before calculus, that is typically what you want to do. You don't want to jump into the calculus right away unless you have to. Okay, and then finally, last part of our notes, and then we can have some practice in here. We do a lot of stuff with horizontal tangent lines. So I'm going to tell you how to approach these questions, but I'm also going to try to get you to see why this is so important and why it's going to come up so much. So when we talk about horizontal lines, we already talked about this today, but what kind of slope does a horizontal line have? 0. So if I want horizontal tangent lines, I want to know when the slope is 0, and what's another name for slope? Derivative. So down here, there's going to be a couple book questions today that say find where it has horizontal tangent lines. It's going to be horizontal when the slope is 0, but instead of thinking of slope, think of the derivative. Derivative means slope. So you'll take the derivative, set the derivative equal to 0, and then solve that. That's what we're going to do on these bottom 3 questions in a second. But I also want to give you some context. Well, look at this graph. If this graph represents the distance you are away from home at a given time, is there any points in here that you think there is horizontal tangent lines?
1.
Okay, at x equals 1, I agree. Looks like the slope is 0 at that instant. What else? 1, okay, 3 looks like it. 5 looks like it's there. And then that's probably it. This one's pretty close, but not quite. But more importantly, if this is supposed to be as time changes, and this is the distance away from home, so it's like he's away from home, he's getting closer to home, he is at home, he goes away from home in the other direction, he comes back to home. But what do these mean? What does it mean when you have these slopes? Good. So he's probably at rest, right? He's either changing directions. You can't change directions without at least for a moment stopping. Or I don't know, maybe he's tying his shoe here or something, but he's stopping. So more importantly, what do all of these slopes represent? Not just the horizontal ones.
How fast he's moving.
Very good. Speed, or more specifically, velocity. So one of the things we'll talk about tomorrow is this is like a position equation. I know where something is based on the time. The derivative of position is actually going to give you information about his speed or velocity. So derivative is not some like abstract thing that we just do to see if we can keep up with it and do it. There is lots of real world stuff to it, and one of the first ones is you take the derivative of position, or you think about the slope of position, and you know something about how fast he is. You know something about his speed. But we tend to talk about velocity. So just a little bit of insight to one of the real world things that we do. Okay, let's practice a couple of these horizontal tangent lines. So as I just said, horizontal lines have a slope of 0, and calculus slope means derivative. So if I was asked to find the horizontal tangent lines of this, I would know to set the derivative equal to 0. Now, I've said this a few times, but I told you guys that you were going to get sick of me saying this the first few months, but I really just have to make sure that this thing's in. The power rule, which was calculus, took me about 2 seconds of work. Knowing why I set this equal to 0, I guess is also calculus. But the majority of my time and effort and mistakes are going to come from the algebra and solving this. So you got to subtract the 1, divide the 3. You've got to take the square root of both sides. Don't forget plus or minus. And what happens when you try to take the square root of a negative number? Okay, and where do imaginary numbers show up on a graph? They don't. So this guy has no horizontal tangent lines. And of course, if you didn't believe me, you could graph that in your calculator, and there's not even one single instant where that graph is temporarily horizontal. And I was able to figure that out here. So, example 1, we can see occasionally we need to think about imaginary numbers. Example 2, horizontal tangent lines are when the derivative equals 0. That's how long it takes me to find the derivative. That's how long it takes me to set the derivative equal to 0. And it might take me 5 minutes to solve the question. I could subtract the 1 and divide the 4. Maybe I'll switch these two. And then some people are going to get stumped here, because it just depends on how well do you remember this from a past math class. How do we solve something like that? Okay, so if you're trying to solve exponential, you need to deal with logarithms. You could either take the log of both sides, natural log of both sides, or I'll just I'll switch the forms, I guess. Switch it from exponential to logarithmic, and it looks like the answer is the natural log of negative 1/4. That sound okay? That's not the answer. What is the natural log of negative 1/4? See, now in a second, I'm about to say something and then you're going to remember it. This is what I'm talking about, where the algebra becomes the hardest part of calculus. You can't take the log of 0 and you can't take the log of a negative number. That also doesn't have any horizontal tangent lines. That doesn't make sense mathematically. There's no exponent on e that would ever give you negative 1/4. So again, I'm just trying to show you we've got to be very good at the calculus and understanding why we set it equal to 0, because sometimes you're still going to have 5 or 6 steps. That might be something about imaginary numbers, or it might be something about logarithm properties. And you will get better at those things throughout the year because they keep showing up. But it does take practice. And then this one will show you that sometimes you need to know the unit circle. So horizontal tangent lines are when the derivative equals 0. So I did the power rule for the first term, and I know the derivative of cosine is negative sine, and I already set it equal to 0. You start solving. Looks like the answer comes from when sine is square root of 3/2. We want to know one rotation around the unit circle. So where is sine square root of 3/2?
Pi over 3.
Okay, pi over 3 is 1.
Negative.
Negative's not going to be between 0 and 2 pi. Sine is the x value or the y value of unit circle? Yeah. So just think about where else has the same y value then. Same y value is over here at 2 pi over 3. So just a third example where I'm showing you derivative may not be difficult, knowing why you're setting equal to 0 might not be difficult, but if you're rusty with unit circles, sometimes that can add a little extra hurdle. If you're rusty with solving exponential equations and using logarithms, that can add an extra hurdle. If you don't understand why imaginary numbers wouldn't show up on a graph, that could be an extra hurdle. So it's not usually the power rule, it's usually the algebra. So I would recommend that you keep this one out, especially since you don't have these things memorized. But is there anything you would quickly like to clear up about this handout? Okay, then with your blank piece of paper I asked you to get out, if you'd go ahead and copy down the assignment, please. It does look like a long assignment, but I can actually do 4, 5, 6. I can actually do like the first 8 of those questions in about 45 seconds. Now, I can do them a little bit faster because I have that stuff memorized, but you're going to see that they're pretty quick. So, blank piece of paper, copy the assignment down, go ahead and start the first few questions. Again, please don't write on the book pages. These are not yours to keep. You may also notice that if you turn the page, I did include the odd answers. So normally if you have a textbook in front of you, you would need to flip to the back to check your odd answers, but I printed that off and stapled it to this, so it's there included. So let me give you some time to get started there, and then I will come in and help. Other than our slow start this morning, I would say that I think probably, if you don't finish this in class, you'll be very close to finish this in class. So. can't take this. You'll have to give this to the office. All I can do is say that you were, wait, they have to change it to documented. Okay, let's talk about the first several, because I told you that they should be quick. What did you get for an answer on number 3? Okay, and the answer is 0 because the derivative of the constant is 0. What about number 6?
12x.
Very good. It's just power rule, so 12x to the 11th. Number 9, you need to change to x to the 1/5. But then when you do the power rule, you should get 1 over 5x to the 4th. So just regular power rule. What would the slope of that equation be in number 12? Everybody see the slope would be 6? And slope, same thing as derivative. So the derivative of 12 is 6. Number 15, looks like you should use the power rule twice. 2x plus 12x squared. 18, looks like you should do the power rule twice and know the derivative of a constant. 6x squared plus 12x plus 0. Make sure you don't say minus 1 there. The derivative of the constant is 0. 21, power rule and one we memorize. 2x plus 1/2 sine x. And 24, 3/4 e to the x minus 2 sine x. You guys okay with all that? So I'm just trying to point out by going over those so fast that you don't have to know a lot to do basic derivatives. You have to memorize a couple things. You have to know how to apply the power rule. But then when you get down to question 27, a lot of my other classes asked about this one. So I'm going to go ahead and talk about it as well. Just to make sure you're aware of the directions. But here's where it starts to be a little bit harder at question 27. They give you the function. And honestly, the part we care about is right at the end. We want to know what is the simplified derivative. But before you can simplify the derivative, you have to find the derivative. And before you can find the derivative, you need to rewrite this, just like we did in the notes. This is not in the right format to do the power rule. You could cube this to get 125x cubed. I have no problems with the 6 over 125. That's just a number. It's not a nice whole number, but it's just a number. But I can't do the power rule when x is in the denominator. So you've got to move x up to the numerator. This would be the rewrite step. And the point is you're rewriting it so that you can take the derivative. You can bring the power down, lower the power by 1. And then they want you to simplify because you shouldn't have a negative exponent in your answer. X to the negative 4th in the numerator is the same thing as x to the positive 4th in the denominator. So they're actually trying to help you by making you write out all 3 steps. Rewrite it before you try to take the derivative, and then once you take the derivative, make sure it's simplified. You should always do that, but on these first 27 and 30, I think, they're just pushing you in that direction. So let me give you a little bit more time, please, and keep going. Okay, and of course, as you guys are figuring out, you know, I'm going to interrupt every once in a while to work out some questions on the board. But you don't have to wait for me to ask. If y'all get to something and you're stumped on it, I mean, you shouldn't ask the first 5 seconds, but if you're really stumped, then just go ahead and ask. If you have that question, then other people probably have the same question, so. Okay. Gradebook's not going to show you that.
That's a good job.
It's from last year.
Thank you.
You weren't here when I passed it back or something. It looks like something you need to review, though.
For sure. Absolutely. Yes.
What was that score?
It's low. Definitely not my best skill.
Okay. Y'all found a question or two I can help with?
Should do 36.
36. Okay, 36. Find the slope of the graph of the function at the given point. So I hear slope, so I know that means they want derivative. So take the derivative. This is going to be -2 times the derivative of cosine, which would be negative sine. What's the derivative of 5? Okay, 0, so I don't need to write that. So this is like a formula that will tell me the slope at any given time. It's just for this question, they want you to say what's the slope at the time pi. So the derivative at pi is 2 times the sine of pi, which is 0. Okay with that part of it? Now you might be like, why are they giving me an entire point? Because they're trying to get you to think about which one of these do you need. If you want to know the slope at this time, you should be plugging in the x value. Sometimes they're going to give you the point, and like we talked about on the notes, instead of saying the derivative at that instant, they might want the entire equation of the tangent line, which is where you might want to know the point for y1 and x1, but the slope is going to have to still come from the derivative. So that's one time where they would need that. Also, there's a part in this question, and they will ask you this again when you get around question 53. It says use the derivative feature of a graphing utility to confirm your answer. So I didn't talk about this in the notes, and it's not that important today, but it is important that you know that your calculator can do some derivatives. The reason why that's important is because your AP exam, which means some of our unit tests, sometimes you're going to need to know the derivative of something, and it's not going to be one you can do by hand. It's not that you weren't paying attention in class. It's not that it was just too hard. It's that some stuff we cannot do by hand. But if you do alpha window, is where I find it, this option 3 and 4, your AP exam will ask you to use both of these. 4 is about integration. That's most of next semester. 3 is about derivative. So you have to define the variable. We're going to take the derivative with respect to, well, technically it was t, but I'm just going to use x. we took the derivative of -2 cosine t plus 5. But before you get too excited, your calculator has not been programmed to be powerful enough to do derivatives for you. That being said, it can do derivatives at a specific value. So if you want to know the derivative at 1 or pi or 7, then it can do that. But it often has a little bit of a rounding error. So we said the answer to this was 0, and you can see it's trying to say 0, but just the way that it computes it, it has a little bit of an error to it. So that's what they're asking you to check. I think it's good for you to practice doing that, because otherwise you will forget that that's a possibility. So again, to find that, I just did alpha window, option 3. Pick the variable you want, put in what you want to know the derivative of, although there we go. It actually, the first time I typed that in was incorrect. I knew it was supposed to be 0, and I thought that was a rounding error. It usually does have a rounding error. But calculus always, always, always in radians. It's not like pre-calculus where half the class is in degrees and half the class is in radians. Everything in calculus is in radians. Every math class you ever take above calculus will be radians only. So now that I switched my calculator to radian mode, you can see what it tested. Yeah.
So you plugged in pi because you started with cosine? Like, why did you plug in pi instead of
Because it's asking for the x value. It wants to know the derivative when x is pi. We can't say when is the derivative have a y value of 7, because it could have multiple times where the y value is 7. It wouldn't know which one we're talking about. There is only one time that x could be pi, so. Yes?
Just curious, on the AP exam, you have to hold the test calculator, or there's like portions with and without?
Half the test is calculator, half the test is no calculator. Half the points you can earn are calculator, half the points you can earn are no calculator. However, just because a question is on the calculator portion of your test doesn't mean you need a calculator. So I think your calculator portion of your AP exam is like 15 multiple choice calculator questions. You probably only need the calculator for 2 or 3 of them.
And there are a few FRQs.
Okay, and then you do 6 FRQs on your AP exam. The first 2 allow a calculator, the last 4 do not. So a lot of times what happens is on the first 2 FRQs, you'll know that you need to take the derivative of something. It'll be something that's not something we memorize. It's not power rule. It's none of the stuff we're going to do next class. They literally, the only way you can do it is with the calculator. That's why if you don't practice doing this occasionally, you forget that that's an option, and then when you see that, you just don't know what to do. So, and vice versa, even if you did know how to do it, if you had a calculator in front of you, why would you take the time out to do that? Just plug it in and get your answer. So. Okay. So I didn't mean to go on a 10-minute tangent there, but I didn't mean to make that reference. But y'all have heard that saying before, off on a tangent? Do you understand where that comes from now? A tangent line, like here's the conversation, and then you go off on a tangent. Tangent line? No, that's really where it comes from. Off on a tangent. Okay. Does somebody have another question or two I can help with? I will talk about at the end of class that I've got help for you on the website. But of course, while you're in here, you might as well ask me.
Could you go over 42?
Sure. 42. So again, because there's going to be help on the website, you don't have to jump to question 42 if you're not ready for question 42. That's fine. But also, you might keep in mind, if somebody else is asking, you might need to ask too. Okay, this you may not do power rule on. This is not a power rule question. it would be nice if you could just do the power rule to the numerator, then do the power rule to the denominator, and then slap a division sign. You can do limits like that. You cannot do derivatives like that. This is what we would call a quotient rule. Quotient means divide, and that's one of the two formulas we'll talk about tomorrow. But in the meantime, we need to find a way that we can make this look in the right format so that we can do the power rule. So to me in this question, I would split apart this fraction. You can never split apart denominators, but you can split apart numerators. So I can put this over x to the third as long as I'm willing to put this over x to the third. You're just used to going this direction. You're used to adding or subtracting fractions and getting a common denominator, but in calculus a lot of times we split them up or go the other way. The reason this helps is this simplifies and this simplifies. And now that I have rewritten it in a nice looking format, I can do the power rule once, bring the power down, lower the power by 1, and do the power rule a second time. But if you don't think to split apart your fraction, then you don't know how to do that derivative. You cannot just pick and choose. You can't say, I'm just going to do power rule over here and then power rule over there, and then I'll combine them or something. Don't try to do that. That's going to give you issues. Okay, is that enough for 42? Anybody else going to ask about 42 while it's up? Okay. Anybody who has not asked the question yet today have one? Okay, keep going. Actually, we got about 25 minutes of class, so I'm going to set a 15-minute timer. So I will come back and ask you for questions in 15 minutes.
I have a question. This way, on this, you distribute the x, and you get x squared plus x, and you get 3x squared plus 1.
That looks good. Let me look at it just to be sure there's not something else.
45.
Yep.
Yeah, okay.
It's a touch early, but is there another couple questions I can help with? Sure, 48. The good news is 48 is at least in the correct format for the power rule. So this is the function, this is his derivative. So power rule here, bring the power down, lower the power by 1, which would make it t to the negative 1/3. I'll move it down to the denominator, which will make it t to the positive 1/3. You okay with that? Okay. Same thing over here. So minus, I'm going to bring the power down and lower the power by 1. So when I lower the power by 1, that's going to be t to the negative 2/3. I'll move it to the denominator, which will make it t to the positive 2/3. And then one of the most common mistakes that I've seen in my other two AB classes is people doing this. But the derivative of a constant is 0. So that part goes 0. I don't know. And then that's it, unless they tried to simplify it or something. Is that what they answered? Oh, well, it's not an odd question. So, yeah, I would stop there. Tomorrow we'll talk about, sometimes it's a pain because, like, you could maybe get a common denominator here, so you could write this as one big fraction. But
Sorry.
are you throwing it at me? Jeez.
Thank you.
Okay, somebody over here had a question, I thought. No? Okay, I must have missed. Something else I can help with? Yep.
45.
Okay, so 45 is this. Does this look like the right format for power rule? So if it's not, make it look different. Get a common denominator. Move things from one side of a fraction to another. Or in this case, you could just distribute. And now that I've distributed, the derivative will just be power rule twice. So this is what I was saying by anytime you can do some basic stuff first, basic algebra before calculus, you probably want to. If you can distribute, it's probably easier if you distribute and then do the calculus, and instead of trying to just do calculus at the very beginning every time. Yeah, what you got?
Did you do 50?
54? Okay, so to do question 54, you got to, again, just like I said on the last question, but instead of distributing, it's different algebra stuff. But you have to know that a fourth root is the same as an exponent of 1/4. And this doesn't look right yet. I need to move this up, which would make it x to the negative 3/4. And once it looks like this, this is the power rule format. So now I can quickly do the derivative and bring the power down, multiply it by the 2 that was already there, lower the power by 1, and so technically that is the derivative, but I know they're going to want this to be a positive exponent. Also, I might as well reduce this. 6 over 4 reduces to 2 over 3. So there's the derivative, which is sometimes what you want. We talked about this in the notes. But this question wants some other stuff. It says, find the equation of the tangent line at the point. This is question 54. So the point is supposed to be 1, 2. So tangent lines are always linear. Use point slope. They're giving you the point. So plug the y value in for y1, plug the x value in for x1, and the only mystery left is the slope. Well, I want to know the slope when x is 1, and the way you're supposed to know that is with derivative. Derivative is a formula that will tell you the slope of this guy anywhere you want. So if I plug a 1 into this, it just comes out to be -3/2. So that's the actual answer they want. Again, just a couple words difference in the directions changes just finding the derivative versus finding the derivative so that you can find the derivative at 1 so that you can plug that into the equation of a tangent line. They gave you all the pieces other than this. So, and then they also asked us to do this with the calculator, so I'll say that part one more time. Alpha window, option 3, I could ask it to tell me, please tell me what the derivative of 2 over x to the 3/4 is when x is 1. And that looks, again, sometimes there's a rounding error, which is why it's problematic to do this only. But when I compare that to our work, I said the slope during that instant was -3/2. And that is looking like -3/2 with just a touch of rounding error. So that makes me feel better about my derivative and makes me feel better about my derivative at x equals 1. Okay, we are down to about 11 minutes, so let me tell you where we need to be for tomorrow. You don't have to pack up yet because you've still got a few more minutes. But I need you to finish practicing the rest of these questions. So if you don't finish in class, you should have just a couple left. And there's a good chance that you might need help on a couple of these while you're gone. So I will remind you on our class website, the one I asked you to bookmark at the beginning of the year. If you scroll down to this assignment near the bottom, assignment 17, you can see all of these have already been worked out. So if in doing your homework you end up needing help with number 60, all you need to do is click number 60 and there will be a video of me going over just that one question. So it's very direct. You can see it was only like what I was trying to show an ad, but it was less than 2 minutes to go over that question. So you need to finish up practicing all of those. You need to use the class website and watch a video or two on any of them that you need help with, and I will take this up tomorrow. So like I said before, our last quiz being the B day, I don't know, sometimes you'll get extra time, sometimes you get less time. You got more time before the quiz because you had the whole weekend, but then on B weeks like this, you've got less turnaround time between Thursday and Friday, so nothing we can do about that. But okay, any questions about where you need to be by tomorrow morning? I will also add that the more comfortable you can feel with these topics, the better, because tomorrow we're going to talk about product rule and quotient rule, and you still have to know the derivative of a constant is 0. You still have to know the derivative of sine and cosine. You still need to be able to do the power rule. We're just going to be adding an extra layer to that. So, okay. And of course the agenda is up on our class website. And again, I know it's a little bit early, but I think, I could be wrong. Is this the, have y'all seen this puzzle before?
Yeah.
Okay. What about this one? Okay. This one's not so much a puzzle, but just something a little bit different. So, anyway, you got about 9 minutes till you're dismissed. If you do find any math questions while you're still here, just let me know. Have y'all seen those before? Those type of things? Remember, you should not keep these book printouts, please. If you're done with them, you can just raise them up and I'll print take them from you. If you're still using it, I'm just gonna put them on the pile by the door, so you can just put yours at the door when you get there.
Where'd you go for that?
Again, I'm gonna put them right here. If you're still using yours, it's fine. Put it there.
Maybe I'm wrong. Wait, but you really know what about me?
Yeah, that's like, if, I don't think they're gonna just like, don't wanna like, that big mess. I feel like, they describe it as like, beautiful and rose combined. It's like lusty and some
The certain people it's talking about
like
that are
they have nothing else to do. They like have
that
introductions
are able to write letters.
I was like water bottles and then like keychain on it.
I was hoping to be like,
It's cool, you can read it. I mean, I can a little bit of it.
Yeah.
Prove how mind can do amazing things.
I'm sure you can read this word.
Yeah.
Yeah, and this one.
That's more mind to read right there. With, mind,
Yeah.
proud.
These two words you can read.
Where are you here?
Huh?
Where are you here?
You can read those two.
Yes, exactly. Yep, that's those are my words.
Today's puzzle.
Yeah. Well, we were done at like 12:30 with the head there, we're like, we like asked the board to move, it's like, no, shit, not it. Yeah, and then we got done early, so I got called.
looks like it's if your mind can read that message. No, the happy holidays we did not. Teacher, it was so good. Is anybody at Peter Square? No, are you? They didn't. Nobody had done it before, so it wasn't like presented to us very well. Yeah. So
It wasn't, but I was like, it's new, I think it'll be, and it wasn't my conference either, but, no, I had that was like my sixth.
elementary school was not my fault.
Really? How? I was gonna go to we're already going to elementary school.
They were the same elementary school. My buddy, I saw my buddy. And he was like, but it's okay, all no, bro, these girls came over and were like, what's your name? And I was like, Mia. And they were like, what's this? And I was like, no, like, they were like, what am I holding? I was like, nothing.
Are you talking about the,
Yes, they got me.
oh yeah.
I didn't even type it. They said, stop it. I said Mia knows nothing.
Oh. And then you said you hated me.
Oh my gosh. She was like, open the gate. Who do you like? And Gabby was right there, so I was like, Gabby. And then she was like, close the gates. And I didn't. She was like, you hate her. And I was like, what?
No one I don't but
Either. Well, actually, she looked at me and said, you date me.
no, that was the second one.
Okay.
It was like who do you hate, and you went not Gabby, and then you went that's who you date.
I didn't. I was confused.
Guys, I need to get a new buddy.
Really?
No, I'm moving.
Wait, what?
Do you have to clone? No, I don't have to clone anymore.
Osama in Hollow.
No, I talked to him. Just I think it's the other way around. I think Colin's actually
The girls love Colin.
okay, ladies, what? Did y'all see Grace? I think I was close. Wait, are you? He should have came back. Yeah, that's what I thought.
He was going.
That's why I thought.
Yes. The one with the watch and the chain.
Yeah.
Yeah, I was like, who's really watching that? And then they were like, I was saying his pants were like decked out chains.
Yeah. Like, bro, you have to go out like 6 months.
He has like decked out, like they were sparkly.